In the early hours of June 23, 2025, beneath the inky skies over Florida's Space Coast, SpaceX once again captured the world's attention with the powerful liftoff of a Falcon 9 rocket carrying 27 Starlink satellites. The launch, which occurred precisely at 1:58 a.m. Eastern Daylight Time from Space Launch Complex 40 at Cape Canaveral Space Force Station, was the latest in a relentless series of missions aimed at expanding the company's massive Starlink megaconstellation. Dubbed Starlink Group 10 to 23, this mission played a crucial role in both enhancing global broadband coverage and demonstrating the technological and operational superiority that SpaceX has cultivated over more than a decade of spaceflight innovation. The launch proceeded with flawless precision. As the engines roared to life and the Falcon 9 soared into the night sky, it marked the beginning of another major step in building what may become the largest communication network in history. Within minutes, the rocket reached the edge of space, where stage separation was executed cleanly. The second stage continued its trajectory toward orbit, while the first stage booster, B-1069, prepared for re-entry and recovery. For the 25th time, this booster performed a controlled descent through Earth's atmosphere and landed successfully on the autonomous drone ship, a short fall of gravitas, positioned in the Atlantic Ocean. This remarkable achievement further underscores SpaceX's dominance in rocket reusability, a key factor that allows the company to maintain an extraordinary launch tempo while keeping costs significantly lower than traditional space launch providers. Booster B-1069's 25th landing was not just symbolic, it was historic. The level of confidence and performance required to reuse a single booster 24 times and still maintain mission success rates at near perfection is a testament to the engineering rigor behind Falcon 9's design. It also highlights the industrial efficiency that SpaceX has pioneered. Every reused booster represents millions of dollars saved and countless hours reclaimed, savings that feed directly into the scalability of Starlink and future deep space missions. Roughly an hour after launch, the second stage completed its deployment maneuver, releasing 27 Starlink version 2 mini satellites into their preliminary low Earth orbit. These satellites represent the newest generation in the Starlink family, boasting upgraded phased array antennas, more efficient solar panels and inter-satellite laser links, a key technological advancement that enables data to be relayed from satellite to satellite without needing to route traffic through ground stations. This allows for improved performance in remote areas such as oceans, polar regions, and areas without terrestrial infrastructure. It also reduces latency and opens the door for global, uninterrupted connectivity that doesn't rely on traditional fiber optic infrastructure. As of June 28, 2025, following this and subsequent missions, SpaceX's Starlink constellation includes 7,926 satellites in orbit, with over 7,900 of them actively serving global users. These numbers are not just numerical milestones, they represent a sweeping transformation in how humanity connects. From rural villages in Africa to research bases in Antarctica, and from mountaintop towns in South America to disaster recovery zones in Southeast Asia, Starlink has delivered broadband internet where no cable or tower could reach. It's not hyperbole to say that Starlink is reshaping the landscape of global communication. Yet this mission also has broader implications beyond consumer internet access. The expansion of Starlink supports critical infrastructure for governments, militaries, aviation, and maritime industries. During geopolitical crises and natural disasters, Starlink terminals have become lifelines, restoring communication when all else fails. This dual-use nature of the network, civilian and governmental, makes it one of the most strategically important private sector space assets in the world today. The timing of the June 23 launch also aligned with a critical period in SpaceX's 2025 launch calendar. Just 2 days and 8 hours later, the company returned to SLC-40 and launched another Starlink batch, setting a new record for the shortest turnaround time between Falcon 9 launches from the same pad. This logistical feat was made possible by improvements in booster refurbishment, pad operations, and mission planning, showcasing a launch rhythm that approaches that of a well-oiled airline operation rather than a traditional aerospace schedule. The implications of this relentless cadence are profound. With a goal of deploying up to 12,000 satellites in the initial phase, approved by the U.S. Federal Communications Commission, and with ambitions to eventually scale up to 42,000 to 48,000 satellites, SpaceX is building the first true space-based communications infrastructure. This constellation, when complete, will be capable of supporting autonomous vehicles, AI-driven agriculture, remote telemedicine, immersive education in remote communities, and seamless global communications for everyone from travelers and sailors to researchers and humanitarian aid workers. Moreover, each Starlink launch acts as a rehearsal for even grander ambitions. The same engineering backbone that makes Falcon 9 reusable and Starlink scalable is being refined and adapted for SpaceX's next-generation Starship vehicle. A fully reusable super heavy lift rocket designed for missions to the Moon, Mars, and beyond. Starlink revenue is widely believed to be key to funding this long-term vision. As such, every successful deployment of Starlink satellites not only enhances Earth-based connectivity but also funds humanity's expansion into the solar system. SpaceX's ability to dominate both terrestrial and orbital infrastructure development in parallel is unmatched in the private sector. While competitors such as OneWeb, Amazon's Kuiper, China's Guowang, and the European Union's Iris Superscript 2 constellation are still in early phases of deployment or testing, Starlink is already fully operational, widely adopted, and rapidly scaling. In conclusion, the June 23 launch of 27 Starlink satellites wasn't just a successful mission. It was a symbol of SpaceX's unmatched capacity for scale, speed, and vision. It further solidified the company's control of low Earth orbit satellite broadband and highlighted the broader impact Starlink is already having on global communication. As each launch adds more nodes to this growing orbital web, SpaceX moves closer to realizing a future where high-speed internet is available everywhere on Earth, and eventually far beyond it.